This is Madan sir here, and I have brought another video for you, and it's from the haloalkanes and haloarenes. And like most of the time, I've been saying this is really going to be very, very important. Why? Because I'm starting, the chemical properties of haloalkanes and haloarenes, and there, you will, learn about what are SN2 and SN1 reaction. Today, I'll be doing only the SN2 part and what is nucleophilic substitution reaction. So I hope this is going to be interesting, and along with that, it's going to be exciting and easy as well. Active. So the first thing I'm talking is, why or what makes haloalkane reactive. So this is our first question. Reactive. So if you understand that the bond between alkyl group and halogen has a dipole moment, and that net dipole moment is towards the halogen. So the carbon has a partial negative charge and halogen has a partial negative charge. Sorry if I said wrong. R has a partial positive charge and halogen has a partial negative charge. And all such bonds are called polar covalent bond. Polar covalent bond, which I'm damn sure you know about. Now the thing is that because this bond is polar, because Rx bond is polar, it is reactive. It is highly reactive. It's also because R is electrophilic. R is electrophilic, I hope you do know, while X is nucleophilic. X is nucleophilic. So I give you two reasons. The first, and this is the second one. Let me repeat back the whole thing. All the haloalkanes are reactive, and it's because, the bond between carbon and halogen are highly polar. And because they are polar, so there is a dipole moment, and because of that, the halogen is partially negatively charged and the alkyl is partially positive charged. So due to the change in the electron polarizing power, this bond is reactive, where alkyl group itself is electrophilic, while the halogen itself is nucleophilic. So these are the two reasons what makes the haloalkanes to be highly reactive. So now the question is, how many types of reaction haloalkanes can undergo? So the first reaction undergo is nucleophilic substitution reaction. And the second reaction they can react with metals. That's a different category of reaction. I'll tell you some other time. And the third, they can undergo electrophilic substitution reaction as well. Electrophilic, reaction, just electrophilic. So we have come to the type of the reaction. Now let's talk about what is this nucleophilic substitution reaction. Haloalkanes exhibit two types of substitution reaction. One is called SN2 and other is called SN1. What SN1 is here? Substitution nucleophilic bimolecular and substitution nucleophilic unimolecular. Okay, so S, represent to the substitution part, N represent to the nucleophilic part, and this 2 represent to the bimolecular. What bimolecular means here? They, or this reaction follow second order reaction. Second order reaction. If you remember this from chemical kinetics, only then you will be able to get what this 2 here. So this 2 represent to the order of reaction. Similarly, this represent to, it follow first order reaction. First order reaction. What did it mean? That the order of reaction is 1. Let me repeat back the whole thing. See what happened in this case, that the reaction between haloalkane and a nucleophile result formation of R plus halogen. So this reaction is dependent over both of the reactant molecules. So that's why the order of reaction is 2. Order of reaction equal to 2. Let's talk here. There, nucleophile, when react with haloalkane, it again forms similar product, but I'll tell you some other thing also, but in the detail section. So it forms nucleophile and similarly halogen replaced. But in this case, order of reaction depends on only one of the reactant. Only one of the reactant. And therefore, the order of reaction is 1. So this is what the introductory part is, that the haloalkanes can undergo 2 types of substitution reaction. One is called SN2 reaction, other is called SN1 reaction. SN2 represent to substitution nucleophilic bimolecular reaction, where 2 represent to the order of reaction, and the order of reaction in this case is 2. Why it's 2? Because this whole reaction depends on, both of the reactant. The one reactant nucleophile, other is the haloalkane itself. But the SN1 represent to the substitution nucleophilic unimolecular. Why it's unimolecular? Because the overall reaction order is only 1, where the order of reaction depends on only one of the reactant. But we need to make a move, and let's understand how the SN2 reaction takes place. So this is our main topic is SN2 reaction, right? What happened in SN2? This reaction take place in single step. This whole reaction takes place in just one step. How this reaction takes place and why this is just a one-step process? Let's talk about. There is any haloalkane, and when you let the haloalkane react with the nucleophile, you do understand this. So as I have mentioned that the reaction takes place in single step. Let's go with the reaction right now. This represents to a nucleophile, and this is an alkyl halide. So what happened? Nucleophile is an electron rich. This is an electron rich species, right? And this electron rich species will displace the halogen from right here. So what happened? This reaction, as the reaction start, bond between carbon and halogen, it start becoming weak. This bond start becoming weak. At the same time, a bond between the nucleophile and carbon start forming. So you have to understand that both breaking of the bond and formation of the bond between the nucleophile and carbon, they are taking place simultaneously. from opposite direction. So this is called an intermediate state. This is called an intermediate. This is called an intermediate, right? And as the bond between carbon and halogen breaks, as soon as the bond is broken here, what happened? The configuration of carbon undergo, change, right? So what happened then? The configuration of carbon reverses. What that means? The phase of the carbon changes from rightwards to the leftwards, and finally, nucleophile gets attached to the carbon itself. The nucleophile attaches itself to the carbon. So this is how the product is formed. But the difference is there the halogen was on the right side, but now the nucleophile is on the left side. So this product is called inverted product or inversion. This is called inversion product. This is called an inversion product. Why? Because the configuration of the carbon, has reversed as compared to the previous one. So let me write that statement here. As the bond between carbon and halogen breaks, the configuration of carbon reverse and move its phase towards nucleophile, and hence the product is inverted. The product is inverted. So in order to make you understand, I've tried to explain you even in writing, and since all this happened in one step, you need to understand that this entire process is taking place without any second step. So that's why the order of, so that's why it's a single step process, and it's called, SN2 reaction here. Another thing is very, very important coming up right now is that there are three types of, alkyl halide. So there are three types of alkyl halide. We need to find out what are their reactivity. Order of reactivity of alkyl halide towards SN2 reaction. What we do know that there are three types of alkyl halide. N alkyl halide. What other one is 1 degree alkyl halide. 1 degree alkyl halide. What next is 2 degree alkyl halide. And finally there are 3 degree alkyl halide. 3 degree alkyl halide. Okay, now the question is, what is the order of the reactivity? Let's take example here. This is N alkyl halide. This is 1 degree, and there is 2 degree alkyl halide, and finally there is 3 degree alkyl halide. So I hope you have understand with the help of example. Now the question is, which one undergo the fastest reaction and which one undergo the the slowest reaction? I tell you what, the first sequence is that this one has the slowest reaction. This one has the slowest reaction here. What that means that the 3 degree alkyl halide has the least speed during the reaction, while the 1 degree or the N or the normal alkyl halide had the fastest process. Now the question is, what makes tertiary least reactive here? What makes the possibility of the reaction very difficult here? And the answer is that in case you concentrate here, that in this case, there are 3 alkyl group from either side. So this has, this is, it has more steric hindrance. Steric hindrance towards attack, because it is most bulky. Bulky, what that mean bulky here? It's quite a bigger molecule. But there you have the least steric hindrance because of small alkyl group, and so on. So what I mean here, very, very important thing is that the tertiary alkyl halide is, is not very much, reactive toward the SN2, because it is bulkier, and because it is bulkier, so therefore the reaction is slow. The possibility of the reaction is also very, very low. But N-alkyl halide has the most reactive tendency, because this is quite a smaller group. So nucleophilic attack, you need to understand that the nucleophilic attack in case of N1 has highest, but nucleophilic attack towards the tertiary carbon has the lowest. So that's why this is least reactive, while this one is the most reactive. So this is what, another thing. One more thing I want to make you go through is that, last thing I'm interested in taking is order of SN2 reactivity. Order of SN2 reactivity down the group halogen. Down the group halogen. What that mean? Which X is here most reactive and which one is the least? So the answer is, down the group, like, down the group halogen, reactivity increases. Reactivity increases because bond enthalpy decreases. So what that mean? Ri will be most reactive as compared to RBr, and that compared to RCl, right? And finally RF. So this is what the trend of reactivity for SN2 is. I hope you have understand. Even I have tried my best to make you go through, but I'm really tired right now. But I wanted to complete this video. One thing I want to say is that I was doing this video in the morning here today, but because there was some problem with the camera, so it didn't get completed. And though I was, I kept on, writing and explaining. But right now I have made it possible. So whatever I have, I've tried my best. In case there is anything you have problem with, like I always said, you just need to, let me know what problem is there and how I can, make sure I can change there. Because the purpose is to make you happier, not to make me happier. So in case you feel that, the way I'm saying, just feel, free to comment and say everything you have to say. Honestly speaking, that this video making idea is not something I'm doing for a reason, but the one reason that, reminds me to, utilizing the time in much more aggressive way, apart from what I do almost every day. So that's the reason I thought, I should invest into something where I can, help, people out there. And so that's the motive. In case you like that, so what you need to do is to, keep watching, keep subscribing, and another very important thing, keep commenting about, I'm just, the most exciting part of, this video making, entire episode has been, reading those comments coming from you. So your comments are always welcome. I know you may be critical, you may be appreciating, but that's okay. I'm really, okay with every kind of comment coming out. So with that, I must say thanks for watching, and see you in the next video.